without knowing chapter 4, how will I be able to determine the red area? And here's a hint for you. Is there a way of determining this area? Is there a way of determining that area?
Would it be the interval between 2 points?
Between
0 and 3?
that's it. From d of x dx. But I need to subtract this piece in order to determine that. Minus 15. That's it. This is, and this is it's going to be in the US dollars, of course. I determine this area by subtracting the area of the rectangle from the whole area that I know how to determine because I studied chapter 4. Awesome. That's it. Done. Let's talk about the producer surplus now. Any questions? So now let's talk about the producer surplus. Well, the supply function is different. So here's the supply function. How does this work? Exactly like the previous one. For this number of units, let's say 3, because I gave you the example 3 and 5. So again, this is number of units, and this is price per unit. So this is the cost. Still the same, still $15. But now this piece is the producer surplus. This area is the producer surplus. So what does it mean? It means that we are paying $15, but actually we should have paid less. We are allowing the producer to pocket a tiny bit amount of money that we should be getting, but we are not. So here, for the consumer surplus, we are getting a little bit more than we are paying for. But when it comes to the producer surplus, they also get their little piece that we are paying for, but we are not really getting anything in return. But now, how do I determine the producer surplus? So here's a hint again. I know this area. I know it's 15, from which I have to subtract this piece, the red area. Can anyone tell us how do I determine that red area? In order to determine the producer surplus, I have determined the area of the rectangle, but now I have to subtract the red area. How do I determine the red area based on chapter 4, of course?
Wouldn't it be the definite interval again between 0 and 3?
Exactly, but this time from a different function. Excellent. S of x dx. That's it. And this can be done, this analysis and this analysis can be done for any point, or it can be done for the equilibrium point if that is the problem. So I already have the book ready for us. Here it is. Where are you guys? Let me share my screen. Ready. So let's go back on page 479 for a second at the very bottom. So we can read. D of X, the demand in dollars per unit, that consumer will pay for X units of an item, and S of X is the price in dollars per the supply function that producers will accept for X units. Find part A, the equilibrium point. Part B, consumer surplus, CS, at the equilibrium point, and the producer surplus at the equilibrium point. So we have problems from 1 through 14. So let's start and determine the equilibrium point, the producer, the consumer, and the producer surplus. That's it in section 5.1. We have to practice. I'm on page 4. Let me remove this page because I ended up with too many. Okay, go ahead.
We do 11.
Yes, let's do 11. Perfect. In 11 we have D of X equals 1800 over the square root of X plus 1. And we have S of X equals 2 the square root of X plus 1. Of course, X has to be greater than or equal to 0. We cannot manufacture minus 5 units. Perfect. We're asked to find, first of all, I'm not going to use this page. So we're asked to find the equilibrium point, and then we're asked to find the consumer surplus and the producer surplus at the equilibrium point. No matter what the graphs are, we're not interested to graph these two, but this and this, here's the equilibrium point. So this is always the demand, this is always the supply, this is always an increasing function, this is always a decreasing function. This is the equilibrium point. How do I find the equilibrium point? How did we find it in the review? Anyone remembers how to find the equilibrium point?
You set them equal to each other?
Absolutely, yes. So the equilibrium point means the demand equals the supply. Awesome. Thank you so much. The demand, 1800 over the square root of X plus 1. The supply, 2 times the square root of X plus 1. What type of equation is this? And how will I proceed? Any suggestions on how to continue? Any particular step that we need to perform now?
Multiply square root of X plus 1 on both sides?
Exactly. You're saying cross multiply. Just cross multiply. 1800 equals 2 times 1, which is 2. How much is the square root of X plus 1 times the square root of X plus 1? Square root of X, the square root of X plus 1 times the square root of X plus 1.
Is it X plus 1?
X plus 1. Divide both sides by 2. I have 900. Subtract 1. The equilibrium point has 899 comma something else. How do I determine that something else, which is the y coordinate? I have to present the y coordinate. How do I find the y coordinate of the equilibrium point? Knowing that x is 8. Yes, go ahead.
Plug in 899.
Of course. Right, exactly. Doesn't matter. They're equal, of course. So 899 plus 1 is 900. The square of 900 is 30. 30 times 2 is 60. So we're willing to purchase 899 of whatever units, whatever they are, at $60 per unit. So that means that this is $8.99 and this is 60. I always need this area. So this area of the rectangle will be 899 multiplied by 60. How much is that?
$53,904.
Excellent. So we have the area. Of course in dollars. Perfect. We have that, and now we want to determine two different things. One is this piece, the red piece, which is the consumer surplus. The other one is this orange piece, which is this. Which is the producer surplus. So, we have two very simple formulas. That's my page 5. And what are the formulas in this case? Consumer surplus and producer surplus. We write the formulas and then we determine them. So, how do I determine the piece that is green? I'm sorry, I meant red. Right here. Consumer surplus, this piece. How do I determine it? What do I have to write? From the... Yes, go ahead.
Is it dx?
I can never start with dx.
The indefinite
The definite integral from...
0 to 899.
Very good. From 0 to 899. From the entire area, which is
53,940.
so it's the dx. So from the entire area, the integral from 0 to 899 from dx, which is this, 1800 over the square root of x plus 1 dx, the entire area, from which I have to subtract the area of the rectangle.
Minus 50.
Exactly. And we will find it in a moment. Now let's analyze how I determine this piece. So I determine the red. Now I want to determine this piece because that's the producer surplus. So this is reversed now. From the rectangle, from the area of the rectangle, I have to subtract, from the area of the rectangle, I have to subtract this area. Under this function. So it's still the definite integral from 0 still to 899, but not from the same function, but from x of x. So I have 2 the square root of x plus 1. Of course, dx. So these are the formulas. One more time. To determine the red piece, I determine the entire area under the demand function. The entire area under the demand function, of course, dx, minus the area of the rectangle. Good. Now, for the producer surplus, it's reversed. From the area of the rectangle, I have to subtract the area under the curve or under the function s of x, which is still from 0 to 899, but not from the same function, from the other function, from the supply function. Once I determine this and I determine that, I'm done. I just need to perform the calculations. And that's it. And that's how we determine the consumer surplus and the producer surplus at any point. It happens that they wanted us to determine at the equilibrium point. Okay, so let's calculate. So the consumer surplus, the integral from 0 to 899, I'm just going to rewrite it, you don't have to, over the square root of x plus 1 dx. Of course, minus 53,940, but I have to use a substitution. Can anyone decide what substitution to use?
The square root of x plus 1.
Yes, let's try that. As long as we can find du. Excellent. Of course, 1800 will go outside. That's a constant. But let's find du. Because without du, I cannot continue. This is u. We want du. There's nothing else right now to look at. This is our u. We need du. We cannot continue without finding du. Can anyone help with the du for this function?
Would it be d of x?
So let's go back. I know it's very easy to forget. A few minutes ago, we decided that that was u. And we determined du. Because without du, I cannot proceed. I have to have du. So coming back to our function, we decided that u is the square root of x plus 1. Awesome, excellent. But if I cannot find du, then I cannot continue. Can anyone differentiate this function and give us the du, the differential?
The second plus 1.
So when we differentiate a function, let's refresh our memory on the derivative. We get 1 over 2 the square root of the function times the function prime. So the square root of a function prime is 1 over 2 the square root of the function times the function prime. So in this case, we have the square root of x plus 1. So let's follow the rule and write du. What is du?
Would be 1 over 2 parenthesis x plus 1 parenthesis the power of 1/2.
But negative 1/2 or in the denominator times the inner function prime, which is so we have the 2, we have the square root of the function, but now I need to differentiate the inner function. How much is the derivative of this? Perfect. Times we are finding du. We're not finding the derivative. Thank you very much. Excellent. Great job. Okay, I'm jumping over all this. So we have, as we see here, we have dx over the square root of x plus 1. Excellent. But I need to have a 2 in the denominator. No problem. Multiply the numerator by 2 and multiply the denominator by 2. That's nothing. It's 1. So now 1, or in other words dx over 2 the square root of x plus 1, they're all here. Excellent. 2 times 1800 is 3600. It goes outside. So all I have is the integral from du. Not so fast. When x is 0, what will be the lower limit for u? When x is 0, what will be the lower limit for u?
0.
0 plus 1 is 1. The square root of 1 is?
1.
Perfect. Now when the upper limit, or when x is 899, the upper limit for u is?
30.
Very good. Good. Which function prime is 1? Which function prime is 1?
You said which function prime is 1?
Exactly. What do I differentiate in terms of u? What do I differentiate to get 1? Exactly. But I have to use u. Exactly. But in this case, it's the same thing, but I have to use u. Excellent. So then, I have 3600. 30 minus 1 is 29. Do I have my calculator handy? I do. How much is 36 times 29? 1044 and 2 more zeros. Sounds excessive. Let's take